I'm going to show you a way to do an abbreviated electron configuration. It's a little simpler, a little quicker, takes a little less time, but you do have to remember to follow the same rules. So here's how it works. If I want to do the abbreviated electron configuration for nitrogen, well, nitrogen, you still need to look over here. If you look up nitrogen, it actually has 7 electrons, and we want to figure out where those 7 electrons go. Well, what you're going to start with is the noble gas core, the largest noble gas that will fit within nitrogen. Well, helium holds 2 electrons, neon holds 10 electrons, argon holds 18, krypton 36, xenon 54, and radon has 86. So the largest noble gas that will fit within nitrogen is helium. So I'm going to write that as helium in brackets. What that means is the noble gas or the electron configuration of helium. After that, you got to figure out where to start next. Well, helium holds 2 electrons, and that completes the first period. So after I'm done with the first period, I'm now ready to start on the second period, and the second energy level starts right here with the 2s. Well, this part, the helium, already deals with 2 electrons, so I just have 5 to go. The 2s we know can hold 2, so I'm up to 4 electrons. The next lowest is the 2p, and I can put 3 more electrons there to add up to 7 electrons, which is what I'm looking for. So the abbreviated configuration would be helium 2s2 2p3. Let's try another one. Let's say we're looking at chlorine right here. Well, we know that chlorine has 17 electrons. So I got to figure out where to put my 17 electrons for chlorine. Well, what is the largest noble gas that fits within chlorine? That would be neon. Neon has 10 electrons. So by putting neon in brackets, that really means the same thing as 1s2, 2s2, 2p6. That's the first 10 electrons. Where do you start with? Well, neon completes the second row, so I'm ready to start the third period, and we always start with the lowest one, and that happens to be the 3s. So I have used up 10 out of my 17 electrons. The 3s can hold 2. That puts me up to 12. After the 3s, the next lowest is right here, the 3p, and I need 5 more. So neon 3s2, 3p5. I've got my 10 plus 2 plus 5 is 17 electrons. Let's try one more really, really large one. Let's pick tungsten right here. Well, if you look in the periodic table, tungsten, W, has 74 electrons. And I want to figure out where those 74 electrons go. Well, the largest noble gas that fits within that would be xenon. And by writing xenon in brackets, that really means I've used up the first 54 electrons. So after I use up xenon, which completes the 5th period, the 5th energy level, I'm ready to start on period 6. The lowest one is the 6s, and that can hold a total of 2 electrons. I'm now up to 56. After the 6s, the next lowest is 4f. And the 4f can hold 14 electrons, which brings me up to 70 used. Again, I need to get to 74, so I'm not done. The next lowest is the 5d, and I can hold a total of 10, but I've only got 4 left, so I put my 4 there. This would be xenon 6s2, 4f14, 5d4. Notice I write down xenon, and then I start here with the 6s1, 2. Here's my 4F14, and then I have 5D, 1, 2, 3, 4 gets me to tungsten. That would be how you write abbreviated electron configurations.